Okay, question 42, we're looking at an electrochemical cell with copper and silver. So it tells me that two half cells are joined by an inverted U-tube containing a solution of sodium nitrate. First question, indicate the direction of the flow of the electrons through the wire when the cell is operating. So first thing I would do is I would get out my data booklet. And if I have a look at my data booklet and the electrochemical series, which I've just cut and pasted here, I can have a look to work out which is undergoing oxidation and what's undergoing reduction. So if we remember from our electrochemical series, over here, as we go upwards on the left, it's a stronger oxidizing agent. As we go down here on the right, it's a stronger reducing agent. So I've circled the ones we're looking at here. We've got copper solid, copper 2+, and solid silver and Ag+. So if we remember that the species at the bottom below is the stronger reducing agent. So that means it will undergo oxidation. This species here is the stronger oxidizing agent, so it will undergo reduction. So if we remember that the electrons will always flow from oxidation to reduction, okay, because this would be our, it's going to let me write, this here would be our anode, okay, because it's undergoing oxidation, and the silver would be the cathode. So to answer the first question, my flow of electrons is going to go from the copper to the silver, okay. Part 2, which ions in the salt bridge would migrate into the copper half cell, so this one here, when the cell is operating? Okay, so from my electrochemical series, I already worked out that this one here is my anode, and my salt bridge is made up of sodium nitrate. So when that dissociates, I'd have Na+ and NO3-. Ready? So if we remember that the cations always migrate to the cathode, the anions always migrate to the anode. So that would mean that the ions here, which would go into my copper cell, would be my NO3 or my nitrate. Part 3, state two observations which could be made in the beakers to indicate that the cell is operating. So when we've got it here, when it's operating, we know that our copper is undergoing oxidation. So it's going to lose 2 electrons. Those electrons are going to flow through the wire. My silver, okay, the aqueous silver, is going to gain those electrons and form silver solid, okay. So I would expect my observations to be that this solid silver, this electrode here, would increase in mass, okay, it would get larger. That would also mean that the copper solid here would decrease in mass. And I'd also expect that because I'm producing more copper 2+ aqueous, yeah, because remember it's being oxidized, so it's going from the solid to the aqueous, I would expect the solution here to become more of a vibrant blue, okay? So the blue color would increase in intensity. Okay. Next question. Explain why it would be unsuitable to use a solution of potassium chloride in the salt bridge of this cell. Okay, so at the moment we've got sodium nitrate. Remember, we want to have a salt bridge where these cations and anions won't interact, okay, and a reaction won't occur, okay, because we just want them there to balance out that charge of our electrolytic solutions. So if we had a solution of potassium chloride instead, what would happen is that chloride, if we remember back to year 11, that chloride would react with my silver to form a precipitate. So remember, if silver and chloride react, we get silver chloride, which is a precipitate. Okay, so we don't want that to occur. Okay, so that's why it would be unsuitable. Next part. Okay, a second electrochemical cell was also using the silver half cell was constructed. Would you expect to detect a flow of electrons through the wire? Okay, so what have we got here? We've got silver, okay, so it looks like the two half cells are the same. I've got 0.5 molar and a 5 molar. Okay, so depending on the concentration of these species, we may get a potential difference, okay? We would expect a current to flow, okay, because there is a little bit of difference, but it'll probably be quite slow. Okay, last question. So silver is also used as the basis for some button cells. Button cells are primary cells developed blah, blah, blah. So, and it gives us the equation here. So I've got and a diagram. So I've got to label the positive and negative electrodes of the cell. Okay, so I've got to work out what's undergoing oxidation and what's undergoing reduction. So I would look at this equation and use my oxidation numbers. So if I go through and put my oxidation numbers in, so zinc solid would be a 0. Okay, what else? Oh, silver solid, do the easy ones first. Okay, then let's work this out. And oxygen is -2, so then that must mean that that's +2. Okay, and then over here, each hydroxide is a negative, so then this would have to be +2. Okay, so if I look at my oxidation numbers, I'm going from a 0 to a +2, so that means that zinc's oxidation number is increasing. Really need a pen. Zinc's oxidation number is increasing, and my silver is decreasing in oxidation number. Okay, so if I can increase in oxidation number, that means it is undergoing oxidation. Probably. And this one here would mean that if I'm getting decrease in oxidation number, so that is reduction. Okay, so I've worked that out. Now, how will I apply this to here? So if it's undergoing oxidation, that occurs at my anode. Okay, I know that. And in a galvanic cell, the anode has a negative charge. And I know that reduction occurs at the cathode. Okay, so that would have to be positive. Okay, so then I can look across to my diagram. So here I've got a metal cap and the zinc powder. Okay, so this is where the zinc is being oxidized. So that's my anode, so that would be negative. Then down here I've got nickel or steel, and that's where my silver oxide is. So that must be my cathode, so that must be positive. Okay. Next part, write the half equation for the reaction occurring at the anode when the cell is operating. Okay, so I worked out here before that it's my zinc that's undergoing oxidation, so that's what's occurring at the anode. Okay, so if we go to my overall equation, I know I've got zinc solid, okay, and it's producing zinc hydroxide. Oh, it's really tedious. Okay. Okay, so now if we think back to our COs, okay, so our key elements, adding hydrogen and oxygen. So I've got my zinc, 1 zinc, okay, I've got 2 hydroxide here, so I need to add 2 hydroxide over here. H minus, that's going to be aqueous. Okay, so that's everything balanced there. Now I need to balance my electrons. So I've got, this is neutral 0, and I've got 2 negative charge here, neutral. Okay, so I need it to be 2 negative. So that means over this side, I will have to add 2 electrons. Okay, and that is my half equation for my anode.